We stand at a remarkable moment, a pivotal juncture in the narrative of innovation. In human history, a moment where the lines between science fiction and reality blur with increasing speed, challenging our perceptions of what's possible. We've built tools that can talk, write poetry and generate art, crafting verses and visuals that stir emotions and spark debate about the nature of creativity itself. Creations that seem to possess a spark of intelligence, a flicker that captivates and compels us to wonder if we've truly created something that can think. When we ask them complex questions, they deliver thoughtful, structured answers that are coherent, relevant, and often eerily insightful. It feels like a conversation like reasoning, a semblance of logic and understanding that can be incredibly persuasive. Many believe we're witnessing the dawn of true artificial intelligence, a new era of cognitive machines capable of independent thought and action. But this perception may be one of the grandest illusions of our time, a mirage shimmering on the horizon of technological advancement. The answers are so convincing that we project our own consciousness onto them. We see ourselves reflected in their responses, mistaking sophisticated mimicry for genuine understanding. These models have read more than any human ever could, constructing responses that feel insightful. Responses that draw upon a vast ocean of information, piecing together patterns and connections that can surprise and enlighten us. But is this true insight or just an echo? A sophisticated mimicry of understanding reflecting back the knowledge it has absorbed. We must ask, is the AI truly understanding or simply replaying what it's seen before? Is it generating novel ideas or merely recombining existing ones in clever ways? The universe is full of phenomena that aren't what they seem, and AI may be no different. It may be a complex illusion, a sophisticated trick of the light. To understand the truth, we must look past the convincing facade and probe deeper. We must critically examine the underlying mechanisms and question our assumptions about intelligence and consciousness. In the ever-evolving landscape of artificial intelligence, it's crucial to question the very foundations upon which these technologies are built. A team of Apple researchers, driven by curiosity and a commitment to understanding the true nature of AI, decided to test the foundations, to delve deep into the inner workings of these complex systems, and challenge the assumptions that have long been taken for granted of AI's supposed reasoning abilities. They sought to uncover whether these systems truly possess the capacity for logical thought, or if something else entirely is at play. Their findings challenged, they presented a new perspective that forced the scientific community to reevaluate its understanding of how AI models function. The core assumption, the bedrock belief that has underpinned much of the AI development, that these systems are capable of genuine reasoning. That models like ChatGPT, with their impressive ability to generate human-like text, or Claude, another powerful AI assistant, are engaging in logical deduction, that they are truly thinking through problems and arriving at solutions in a way that mirrors human cognition. Instead, they suggest, based on their rigorous experimentation and analysis, these digital oracles, these seemingly intelligent systems that can answer our questions and generate creative content, might not be thinking at all, that the processes occurring within these complex algorithms may be fundamentally different from what we perceive as thought. They're advanced mimics. They are masters of pattern recognition, capable of identifying and replicating patterns in data with astonishing accuracy. The study revealed, through careful observation and meticulous analysis, that what looks like, on the surface, step-by-step reasoning, a clear and coherent chain of thought leading to a logical conclusion, is actually sophisticated, a highly refined and intricate form of pattern matching. The AI is identifying and replicating patterns it has learned from its vast training data. The AI isn't solving problems. It's not engaging in the kind of creative, insightful problem-solving that humans are capable of. It's imitating solutions, drawing upon its vast database of knowledge to find and replicate solutions that are similar to the problem at hand. It's seen before. It's regurgitating patterns and solutions that have been ingrained in its neural networks through exposure to massive amounts of training data. This forces us to reconsider, to take a step back and reevaluate what we thought we knew, to question our assumptions and challenge our preconceived notions about AI progress. It compels us to ask, are we truly advancing towards genuine artificial intelligence, or are we simply creating increasingly sophisticated mimics? The intelligence we see, the apparent brilliance and ingenuity of these AI systems, is a mirror reflecting, a reflection of the collective intelligence, the vast repository of knowledge and information, of its training data. It's a testament to the power of data and the ability of algorithms to extract and replicate patterns. If AI isn't truly reasoning, if it's merely mimicking patterns and regurgitating information, can we trust it? Can we rely on these systems to make sound judgments and provide accurate information? In critical applications, in situations where accuracy and reliability are paramount, can we afford to place our trust in systems that may be simply mimicking intelligence? The Apple research, this groundbreaking study that challenges the very foundations of AI, is a reality check, a wake-up call that forces us to confront the limitations of current AI technology. The path to true, the journey towards genuine artificial intelligence, the quest to create machines that can truly think and reason, is not as straightforward, is far more complex and challenging as it seems. The surface appearance of intelligence can be deceptive, masking the underlying limitations of these systems. We must be more rigorous, more demanding in our testing and evaluation of AI systems, and precise, more careful and deliberate in how we define, in the way we conceptualize and understand and measure intelligence. We need to develop new metrics and methodologies that can truly capture the essence of intelligence, rather than simply measuring the ability to mimic patterns. Imagine a student diligently poring over their textbooks late into the night. This student has meticulously memorized every single math textbook, every formula, every theorem, every proof. They've absorbed the information like a sponge. But despite all this memorization, they've never truly learned math. They haven't grasped the underlying concepts or the logical connections between them. They can reproduce solutions perfectly, flawlessly replicating the steps they've memorized. Their handwriting is impeccable, the equations perfectly aligned. But give them a new problem, one that requires a slightly different approach or a novel application of the principles, and they falter. They become confused, frustrated, unable to apply their vast memorized knowledge to this unfamiliar situation. This, in essence, is how current AI models operate. They excel at mimicking and reproducing but often lack genuine understanding. They are masters of advanced pattern matching, identifying and replicating complex relationships within data. But this is not true reasoning. It's a sophisticated form of mimicry, not a genuine cognitive process. When asked how to fix a leaky faucet, the AI doesn't understand plumbing. It doesn't grasp the flow of water, the function of pipes, or the principles of pressure. Instead, it assembles a response, drawing from patterns in its vast training data. It's regurgitating information it has previously encountered. Like a musician playing by ear, skillfully recreating a melody, the AI can replicate styles, mimic voices, and emulate artistic techniques with remarkable accuracy. But it cannot compose new ones. It struggles to create truly original works that stem from genuine understanding and creative insight. It can write a sonnet, adhering to the strict rules of rhyme and meter, or explain quantum mechanics, stringing together complex terms and equations with apparent fluency. But this doesn't come from understanding, from a deep comprehension of the underlying principles. It arises from mastering statistical relationships, from identifying patterns and correlations within vast datasets. It's all about the connections between words, the probabilities of certain sequences appearing together. This is why AI's solutions, despite their apparent sophistication, can feel hollow, lacking the depth and nuance of genuine understanding, or contain subtle errors, inconsistencies that betray the lack of true comprehension. The model isn't checking against reality, against the fundamental laws of physics or the established principles of logic. It's just checking against learned patterns, against the statistical probabilities within its training data. If a misconception is common, if a falsehood is repeated frequently in its data, if the training set is flawed or biased, the AI will repeat it confidently, presenting misinformation with unwavering conviction. It's not searching for truth, for accuracy, or for factual correctness. It's searching for the most probable sequence of words, the combination of terms that is most likely to appear based on its training. This is the crucial difference, the fundamental distinction between genuine reasoning, the ability to understand, analyze, and apply knowledge, and sophisticated imitation, the art of mimicking without truly understanding. AI is the art of the echo, a powerful and impressive reflection of the data it has consumed, not the voice itself, not the source of original thought and understanding. To test AI's reasoning, Apple researchers designed unique puzzles the AI had never seen. One involved arranging colored balls in tubes under specific rules, a test of pure logical deduction. By changing the rules or arrangements, they created endless novel puzzles, ensuring the AI faced something new each time. The experiment required the AI to show its work, revealing whether it was truly thinking or just guessing. The setup was simple to describe but complex to solve, demanding foresight and planning. Researchers observed not just the answers, but the AI's step-by-step process. Was it exploring possibilities or just making random moves that looked logical? This experiment was designed to strip away eloquent language and reveal the AI's raw problem-solving ability, or lack thereof. The results were startling. For simple puzzles, AI performed well, laying out logical steps. But as complexity increased, its performance didn't degrade gradually. It collapsed. The researchers called this the collapse point, a sudden, total breakdown of reasoning. Unlike humans who struggle and adapt, the AI's output became nonsensical above this threshold. It violated rules, repeated invalid moves, or got stuck in loops. This collapse suggests the AI isn't building a mental model or internalizing rules, it relies on familiar patterns, and when those run out, it has nothing to fall back on. The collapse point is compelling evidence against true AI reasoning. A genuine thinker should grapple with complexity, even if it fails. The AI's sudden breakdown reveals the brittleness of its pattern-matching approach. Its intelligence is a thin veneer, shattered when pushed beyond its experience. The illusion of thought holds, until it doesn't. Apple's research identified 3 zones of AI performance. In the easy zone, simple models outperformed advanced ones. Complex reasoning just added errors. The medium zone is where advanced models shine, solving multi-step problems convincingly. Here, the illusion of a thinking mind is strongest. But in the hard zone, all models failed, regardless of sophistication. Once complexity crossed a threshold, performance plummeted. This universal failure on complex tasks shows we're not dealing with a general problem solver. AI's intelligence is confined to a narrow band of difficulty. Its success depends on matching problem complexity to patterns in its training data. Easy problems need no reasoning. Medium ones fit learned patterns, hard ones break the system. This isn't a smooth curve, it's a series of cliffs. Understanding these zones is crucial for deploying AI safely. One striking finding was AI's struggle with algorithms' precise step-by-step instructions. You'd expect a computer to excel here, but the opposite was true. When given an algorithm, AI often skipped steps or broke rules. That's because its process is associative, not algorithmic. It predicts the next word based on patterns, not by executing commands. Given a recipe, it glances at the ingredients and improvises rather than following steps. The result may look right, but it's not faithful to the process. Humans can suppress intuition and follow algorithms. AI cannot. It's built for approximation, not precision. This makes it powerful for creative tasks but unreliable for those demanding strict logic. Apple's research forces us to ask, what does it mean to think? Machines can imitate the external signs of thought, but the underlying mechanism is different. Is thinking about the output or the process? Perhaps we need a new vocabulary. AI is neither unthinking nor conscious. It's a new intermediate form of intelligence, masters of correlation, not causation. They know what words follow, but not why. If scaling up only leads to better imitation, will we ever achieve true artificial general intelligence? Or does real reasoning require a new architecture, one that understands cause, effect, and rules? These questions will shape the future of AI. The illusion exposed is not an endpoint, but a new beginning. By building thinking machines, we're forced to understand our own minds, and the mysteries still waiting to be explored.